こんばんは。
Welcome back to my two-part series on objects. This video will be my last in the Intro to Programming series, and after this video I'll be focusing on filling in the gaps from previous videos, discussing more advanced topics, and getting into various data structures, algorithms, and how to use them. But after this video, you should have a good enough foundation to experiment in Java and explore other languages and have a pretty good grasp on how to get them to do the things you want. First, we're going to chat about a subject called encapsulation. Effectively, we care about private things versus public things. What should the world be able to know about you and directly access versus what do you want to keep secret? So you might have noticed how we always have used public this, public static that. Well, public means the whole world can see and access it. On the flip side, private means only the direct class or object can use it. Even subclasses can't access a private method or variable. There's something called protected, which is kind of in between the two, so subclasses can access it, but other unrelated classes can't. But we're going to focus on private versus public for now. There are a few general rules to follow. Variables are always private. Constants are almost always private unless it's being used in a utility class, then it can be public, because the idea is that a bunch of classes are going to use it. Constructors are almost always public. For now, just assume always. Methods are entirely dependent on what it does. If the method will be called by other classes, then it's going to be public. If it will be used internally to support other methods, then it'll be private. This encapsulation principle is based on the concept of need to know. What if some pro hacker hits your system and starts stealing all your objects? Well, you don't want them directly tinkering with things. You only want them to use the stuff you already gave the public in the first place. And now I hear you say, how am I supposed to get values from an object if variables are private? This is a best practice. In order to encapsulate variables, we want to describe how they are retrieved and set. So we wrap our variables in get and set methods. So for our name variable, we would have a get name that retrieves it and a set name that replaces it. And if you only ever want to set it in your code and never really use it outside of your class, well, it's already private, so you don't need to create the getters and setters, and you're done. Next, we're going to cover something called composition. And no, we're not composing a symphony. This is another thing that is essential to how OO works. It is also a primary user of that encapsulation concept. Effectively, composition means that an object can be made of other objects. So maybe we have a new object called trainer. Well, what comprises the trainer? Well, they have a team of Pokemon, a name, a hometown, an age, and a bunch of other random data that kind of describes it. Now, we could declare all of their Pokemon and all of that related data directly in the trainer, so it would have Squirtle, Wartortle, all of its moves, all of the methods related to those, and that would just take up a lot of space with a ton of reuse code for each Pokemon, duplicate variables, and all that. But instead, we can just have an array of Pokemon objects directly in our trainer object. Of size 6, because that's how big a Pokemon team can be, obviously. That way, we can reuse that Pokemon class we already made and save a ton of time and code. So let's try creating this new trainer class. Public class trainer, private Pokemon array, team equals new Pokemon size 6, private string name, private string hometown, private string age, and anything else you can think of. Thus, we now have a Pokemon object that can be used independently, like in the wild, or can be used in a trainer object, or maybe a gym leader object. And now that trainer object doesn't really care about how a Pokemon works, it just knows all Pokemon work this one way, and that's all I really care about. The trainer can focus on being a trainer. This makes your code much easier to maintain because just like having as many classes as you need, you can separate things into sensible buckets and kind of connect them via composition. And there's so much more you can do with composition down the road, but this is kind of that top level of how it works. And when you're discussing inheritance and composition, you start to get into the conceptual topic of abstraction. Abstraction is like the umbrella term for everything that is object orientation and really good coding practices. Oh, you want to share this logic between classes? Abstract it to a parent class if they're related inherently, or to a utility class if they share a similar goal but will be used across many different types of classes. Oh, these variables and methods are actually a different concept entirely. Abstract it to a new class or object type, and then compose those two objects if you want to use them together. Another way to think about it is that you can't always be discussing ideas as code. Oh yeah, I did a for loop and some if statements to adjust my output, blah blah blah. Is really long and tedious to say in every conversation, so you abstract it out to, oh, I did some data processing in this class on this object. Way easier to understand with no additional context. All of these OO concepts and best practices aren't needed for the computer to know what to do, but they're for us to be able to tell other people what we told the computer to do. You want your code to be reusable and generic so it can be reused in as many places as possible. Less code equals less headaches. You want like things to be grouped so that you can talk about ideas, not details. All of this is abstraction. Encapsulation also personifies abstraction. Only let people know at a high level what was going on. Keep those details hidden so that outsiders just assume they work the way they should, even though you know it's all duct tape behind the scenes. Lastly, I want to say that the big four OO topics from this video and the last are encapsulation, abstraction, inheritance, and polymorphism. They are the top level topics that all of the other things I mentioned flow from. I just wanted to kind of cover the others as well, just because you'll hear them used from time to time, and they help contextualize those other four topics. I hope you found this intro series helpful and are looking forward to the more advanced topics I'm going to start to get into in the coming weeks. Hopefully, I can release in a somewhat regular cadence. I'm hoping at least 1 or 2 videos a week, but we'll see if life gets in the way of that. And until next time,
sayonara.
like, subscribe, and comment below what you want to see next or topics you'd like to know more about.